Hello students, welcome back. This video lesson is an optional one. Here we are going to prove the product rule and the quotient rule. The students who are not interested in the proof may just skip, but if you're interested or if you're unsure but you're thinking about mathematics as possible major or minor, please stick around. This is going to give you a very good preview of what's to come. Okay, here we go. Let's begin with the definition of the derivative, and this is it. This quantity here is called Newton quotient, and the limit of the Newton quotient is a derivative. Geometrically speaking, Newton quotient is basically this. It's rise over run, as you can see here. You see? And the difference of y coordinate is the difference of the function value f of b minus f of a, and the difference of x coordinate is b minus a, and they form rise over run, the slope of the secant line. Now if I take the limit, which means this point is getting closer and closer and closer to the original red point, basically we are looking at this kind of situation where all these green secant lines are converging into the red tangent line, and that's the derivative. Now, alternatively speaking, this expression, f of b minus f of a over b minus a, can be rewritten into this f of h plus h minus f of a over h, which we call Newton quotient. By this process, the denominator, b minus h, we replace it as h. Consequently, solving for b, we get b is a plus h. So that's what we get here. In place of b, we get a plus h. In place of b minus a, we get h. And the final quantity here is quite useful, and we're going to use it. Now, here's the product rule, and let's prove it here. We begin with a definition of the derivative using the Newton quotient, and we're going to put f as u of x times v of x. That's the first line. Looks like I'd better increase the font. Okay, that is the first line here. You see, we have f of x plus h is u of x plus h times v of x plus h, because f is u times v, and then f of x here is u of x times v of x. And here in the left hand side we want the derivative of f, so we want the derivative of the product u times v. Everything fits. So the first line is nothing more than rewriting of this. Okay, and then what we have, here in the numerator, we do something ingenious. We subtract and add the same quantity. Consequently, I didn't change anything. It's equivalent to adding 0. The strategic quantity that I'm subtracting, adding, is u of x times v of x plus h. The same thing is subtracted and then added. Why am I doing that? Because this allows me to take first two terms to form one fraction and the second two terms to form the second fraction. Does it help? Yes, it does. In the first fraction like this v of x plus h is common. So I can factor it out, as you see here, color-coded in green. And then what do we have left? What's left is a Newton quotient, u of x plus h minus u of x over h. Compare this Newton quotient with this one. Exactly the same, except of course for the choice of character. So instead of f prime of x, you just get u prime of x. How about this green part, v of x plus h? Because h is going to 0, we get v of x. How about the second fraction? Here u of x is common. So if I factor that out, I'm gonna get this expression, and what's left is a Newton quotient. Compare this with this. Exactly the same, except of course the choice of character, f versus v. So instead of f prime of x, I'm gonna get v prime of x. This u of x highlighted in blue was taken out before, so let's keep that. And then what do we get? U prime of x, which came from this Newton quotient, times v of x, and u of x times v prime of x, which came from this Newton quotient. The product rule. How about the quotient rule? Pretty much the same, as a matter of fact. And let's expand the font again. Here, from the definition of the derivative, we put f as u over v. And then put it here. That's what the first line is all about. The derivative of f is derivative of u of x over v of x. And f of x plus h, you get u of x plus h over v of x plus h. And as f of x, we get u of x over v of x. Too many denominators, so let's do some simplification by multiplying v of x times v of x plus h to both numerator and denominator. So we get this one killed and we get v of x. That one killed, we get v of x plus h. And then we multiply both of them to denominator. So far so good. And then let's do something very, very similar. Subtract and add the same quantity as we have done before. This time we choose u of x times v of x. Subtract that and add it again. Consequently, I just added 0 to the numerator, so no change there. But that allows us to take first two terms to form one fraction, and the next two terms to form the second fraction. In the first fraction, do you see some common term there in the numerator? I hope you can see this v of x. And then this v of x here. You see? Consequently, I can factor that one out. How about from the second? This time u of x is common. U of x is common here. So I can factor it out like this. So after factorization and also getting these denominators out as well, and let's complete this color coding. Okay, get those out. What's left here in the first fraction is a Newton quotient, u of x plus h minus u of x over h. Here, from the second, we get Newton quotient, v of x plus h minus v of x over h. Exactly the same as this, except of course the choice of character. So instead of f prime of x, you get u prime of x here, and then v prime of x there, because this is for u and that's for v. How about the others? Well, this v of x came from that green, the previous, and this u of x not this one, came from this blue, and then the denominator v of x plus h times v of x, because h is going down to 0, we got v of x and another v of x, generating the denominator squared. Where's brown? Okay, there we go. What's left, of course, is the quotient rule. Let's recap this. Put u over v to this form, and that's the first line. Okay, and then a little bit of simplification. That's how you get v squared in the denominator. Strategically add and subtract the same quantity, u of x times v of x, and then take first two terms and then the second two terms to form one fraction and another fraction. Factor out appropriately v from the numerator and then v squared from denominator, u from the numerator, v squared from the denominator. What's left is the Newton quotient for u, the Newton quotient for v. Consequently, we get u prime of x and v prime of x respectively, and the others all colored as before. The final result is the quotient rule. How about the generalized product rule? This can be done by repeated application of the product rule. It works like this. U of x times v of x wx. So if I apply the product rule, so you get u prime of x times v of x times w of x plus u of x, and then you have to take the derivative of the next one. First term is all set. It's u prime of x, v of x, w of x. Next, u of x, and then we have v prime of x, w of x, plus v of x, w prime of x. If you distribute that around, then you're gonna get what you want. The first is all set, and then distribute, then u of x times v prime of x wx. Now multiply u of x there, so no bracket here, but you have u of x there. In the end, what do you get? We have the generalized product rule there. If you do it once more, then you're gonna get the product for 4 factors. Another time, then you're gonna get 5 fractions, 5 factors, 6 factors, and so on. It is nothing more than just repetition of the same product rule, so you can do it inductively. The general case is written there, but I'm not gonna bother doing all those.